Hey guys, today we're going to continue practicing adding and subtracting polynomials. So just so we could have a little bit of reminder, when you're adding polynomials, all you need to do is combine like terms by adding the coefficients. And remember that like terms means that they need to have the same variable, same exponent. When you are subtracting polynomials, you're going to see a minus sign in between them. So first thing you're going to want to do is distribute the minus sign to the second polynomial. Then you can combine like terms by adding the coefficients. Okay, so let's look at the first example that I have here. I have 5m squared minus 8 plus 2m plus 3m minus 2m squared plus 12. So with this example, you need to be careful because the terms are out of order. These polynomials are not in standard form, but that's not a problem. We're just going to pay extra close attention to variables and exponents. So let's start with that 5m squared. When I look at the second polynomial, negative 2m squared is the second term. So we're going to add those up. 5 plus negative 2 would give me 3m squared. Okay, then I would move on to m to the first power, or just plain m. So that's the third term here, plus 2m, but it's the first term in the other polynomial. We're going to add those up. 2 plus 3 gives me 5, so that'll be 5m. And then basically I only have my constants left, so I have negative 8 plus 12, and that gives me positive 4. So there's our answer there, and we went ahead and put it in standard form as we were going along. Okay, let's look at another example. So this time I have 2x plus 3x squared minus 1 minus x squared minus 6. So notice this time that they want us to subtract. So when you're subtracting, the first thing you need to do is distribute that negative sign to both terms in the polynomial that immediately follows it. So for the first polynomial, since we're not doing anything to it, I'm just going to rewrite. Okay, but that second polynomial, this, you can consider it as a negative 1, invisible 1, right? So then, when you distribute it, negative 1 times x squared is just negative x squared. And then for the next term, negative 1 times negative 6, be very careful, negative times a negative changes that to a positive 6. And now that I have distributed that negative sign, now we can combine our like terms. So starting with anything that has x to the second power, so I have a positive 3x squared and a negative x squared. When there's no coefficient, remember that there is an invisible 1 right in front. So really we have here positive 3 plus negative 1, and that gives me 2x squared. Now anything that has an x to the first power, so we only have 1, we only have that very first term. So since nothing is changing, it's going to stay exactly the same. And I put plus 2x because there is no sign in front, so we know that means that it's a positive number. Okay, and then last but not least, our constants. I have negative 1 plus 6. That gives me positive 5. Okay, let's move on to our next example. So this one, it looks more difficult than it actually is, and it's only because this time I have some fraction coefficients, but that does not change the rules of adding and subtracting polynomials. You're still going to add and subtract like normal. So let's take a look. We want like terms, so I see c to the third power. That's the highest exponent, and same thing here. So let's start by combining those. 5c cubed plus negative 2c cubed. So 5 plus negative 2 is 3. Okay, and then on to the next one. I have negative 1/2 x squared and then plus 4c squared. So adding and subtracting fractions, you are going to need a common denominator. So that 4, instead of thinking of it as 4, you can think of it as 8 over 2. That makes it easier because now I have negative 1/2 plus 8 halves, so that would give me negative 7 halves. c to the second power. And then last, we have the terms that just have a plain c. So I have c plus negative 5 over 4c. So remember that that first c that we see there has an invisible 1. But I needed to have a denominator of 4. When you add and subtract fractions, you need common denominator. So instead of 1, I'm going to think of this as 4 over 4. That's going to make it a lot easier to add here, because now I have 4 over 4 plus negative 5 over 4. So that gives me negative 1 over 4c. Okay, let's look at the next one. So same deal. Our polynomials here have fractions. Be careful because this time there is a minus sign in the middle. They want us to subtract these polynomials. So first off, what we're going to do is distribute that negative sign. So first polynomial stays the same, 3b squared plus 2/3 b. Okay, but now we're going to distribute. Negative times a negative is going to make that positive, so positive 3 over 2b squared. Then I distribute to the next one, so that's going to change to a negative sign, 5 over 3b. And to the third one, also turns into a negative sign, so minus 1 over 5. Now let's look for our like terms. So I noticed this first term and this third term both have b squared, so we're going to put them together. Again, we are adding fractions here, so you have to convert that 3, so this 3 here, you want it to have a 2 at the bottom, so you can think of that, instead of 3, you can think of it as 6 over 2. So then when you do your adding, 6 over 2 plus 3 over 2 gives me 9 over 2b squared. Okay, now anything that has a b, I have positive 2/3 b and negative 5/3 b. So we got lucky here. They already have the same denominator, so let's just look at those numerators. 2 minus 5 would give me negative 3. So that would make it negative 3 over 3. But we know that that simplifies to just 1, so I'm not going to write 3 over 3. I'm going to write it as 1. Okay, so that would be 1b. But then again, when you have a coefficient of 1, we don't normally write that, so I'm just going to take that 1 away. It'll just be plain b. Okay, and then last, any constants, we only have 1, minus 1 over 5. So this is our answer right here. Okay, and then I have one last example for us. This is going to be in the form of a word problem, so we're going to have to read it and see what they want us to do. So this says, a shoe company is going to close one of its 2 stores and combine its inventory from both stores. These polynomials represent the inventory in each store. So store A, we say this polynomial is their inventory. Store B, we're going to say this polynomial is their inventory. So what is the combined inventory? If they want me to combine, that means that we need to add everything up. So combined means that we're going to need to add. Okay, so just like the other ones, we're looking for like terms. So in store A, my first term is 1/2 w squared. In store B, I have 4w squared. But you see how they're both w squared? So let's add those up. Remember to use common denominators, so that 4 turns into an 8 over 2. So when you do your adding, that's 9 over 2 w squared. Okay, then I want anything that just has w to the first power. Store B has one. Store A doesn't have one. That's okay. That means I don't need to combine it with anything, so it's going to remain the same, negative 4 over 5w. And then last, we want our constant. So I have 7/2 plus 1/4. So they're both fractions, but they do not have the same denominator. But that's easily fixed. That's 7/2. If I wanted it to have a 4 at the bottom, I could just double it, so it would look like 14 over 4. And now you can do your adding. 14 plus 1 is 15, so this would be 15 over 4. So this polynomial right here would represent the combined inventory of those two stores. Okay, guys, and that's all that we have for adding and subtracting polynomials.